Howdy everybody, Steve here, KM9G. Today I'm going to show you my first Feng. I'm going to show you some of the accessories and some of the ins and outs and gotchas of having a Feng and why these are the best radios on the planet. Let's go. This is the first radio I ever had, the Feng UV5R in high-vis yellow. I'm going to get all the stuff out of the bag and share with you the journey that I was on. First off, somehow I have two Feng UV5R chargers, desk cradle, desk stands. Let's see why. Nope, they are both DC powered. Input power 12 volts, output 8.4, 400 milliamps. Input DC 10 volts, output 8.4, 400 milliamps. Okay. This one only has 2 pieces in it, and this one has 3 pieces in it. I call them pieces because there's a reason why I start off with that. On the back of your Feng radio, you have a couple of different connectors here that you slide in. You can see these are actually kind of worn out a bit. Positive and minus makes sense. I want to get power in and I want to complete the circuit. This one in the middle is for temperature, so you don't overheat the battery while you're charging it. So the better charger to keep is the 3-prong charger, assuming it actually has in it the temperature sensor. It doesn't feel any different in weight. It probably doesn't have the temperature sensor to begin with. We'll leave that off to the side. Then I also have a couple of power adapters, and we looked on here and it said input is DC 12 volts. And this one here, first off, this pin doesn't fit that socket at all. So that's a thing. Why do I have that? And then this one here is output 10 volts, half an amp. So this one here will charge and we'll plug in. Perfect, we're making progress. So why did I have this one? On the side of the extended battery, you get a charging hole. And this fits in that hole, but it is pretty loose. So I'm wondering if it's even making any kind of contact. And then, see if I can even read this, because they made it brown text on a black background. That's not easy to read. This thing might as well be a resistor. So it's regular AC, it's 120, it's 100 to 240 volts input, 50 or 60 hertz. So this will work in every country. And it draws 0.15 amps. And then output is 5.9 volts at 0.5 amps. So that's a very weird power supply, and I have no idea why this thing is here. But what I did find out is it doesn't actually charge this up. So output here is 5.9 volts, and this thing is a 7.4 volt battery. So this will not have enough push to push voltage into this thing. You would need to charge this with something slightly higher than 7.4 volts in order to make it work out. Unless this has some magic circuitry in it, which it might, but unless this has some magic circuitry in it, you're not getting anywhere with this device. This is not going to help you out. This charger is not going to help you charge this battery. So this gets tossed in the trash, and that actually made it into the trash can. Next up, I have one of these guys here, and this has one of those fat connectors on it, which leads me to believe there is something in there, and then it has a 5525 port on the back. And this is typically USB voltage levels, which is 5 volts-ish, and then this thing here is expecting 12 volts. So again, there has to be some type of boost converter in here to boost that voltage up, which there might be. This is big enough to have that. Or there has to be some type of boost converter in here, so we'll check that first. Okay, so now we get out our very simple power meter, and I've had this thing, a very simple voltmeter, and I've had this thing for ever as well. And I want to see what kind of voltages we're getting out of this thing. So it is set for the 20 range, and I want to plug this thing here into a USB port and give it some power. All right, we've got that plugged into a powered USB hub, and we're going to assume it's center positive because that makes a lot of sense. Oh, there is some magic in there, 10.5 volts. Perfect. So inside of this little box here is that boost controller I was telling you about, because it gets it up to 10 volts. And this one here said 12, and this one here said 10. And this one has a model number, this one doesn't. So this one might be dedicated to that USB charger part without the temperature sensor. Let's plug that in. And green indicates that the battery is fully charged and there's no battery on it, so that's telling. Let's put the battery on by itself raw and it turns red. So this battery is in need of a charge and is currently charging. That's funny. This has been chewed up, and I don't know if this was factory chewed and there's a little hole in it there, or if that was something somebody did before they gave it to me. Because like I said, this was given to me by somebody at the club. All right, so that plugs in and it needs a charge. Excellent. So this is a matched set. We'll keep this off to the side as a matched set because we're gonna do something with this when we're all done. And as far as that hole, we're going to assume that it is center positive. It wouldn't hurt if I plugged in center negative and then tested the outside. And so what we're talking about is on a barrel jack like this, there is a conductor on the outside and there is a conductor on the inside. So if I go like this, that number will read positive. And if I go like this, it won't hurt anything. The number will just read negative instead. And so then I know that it's actually center positive. And that's how you can tell what the polarity is of some of these old chargers that you find laying around. And also, that is what this little diagram here shows you. And it shows you a minus sign with a C shape around the center pin. And then it shows you a positive sign that connects to the hole in the center of the C-shaped negative sign. And then this is a 10-volt output, which would go with that as well. So this one here, being 12 volts, will actually work on your benchtop power supply. And then you can go on to Amazon and you can pick up some, short pigtails and put power poles on one end of them and make it into your own thing. So this is still useful even if I don't have a charger for it because I have a 12-volt bench supply. Most bench supplies put out 13.8 and 12 volts is actually not going to be a problem because a lot of times these things have tolerances in them where they'll accept, plus or minus 5% or whatever. So 13.8 is close to 2 volts over, close to 14. It'll also accept close to 2 volts lower because it's trying to convert that input down to 8.4. And what it's doing basically is wasting it as heat and then sending 8.4 out to the radio to charge the battery. So that's still a useful tool to have. So let's talk about this radio here for a bit. This is the much exalted Baofeng UV5R, but it's not just any UV5R, it is a UV5R-B model. And if we take a look under the battery, underneath here, it says Baofeng dual band FM transceiver UV5R-B, power 5 watts, voltage 7.4 volts, and it's supposed to be good for 136 through 174 and 400 through 480. So it'll do 2 meters and 70 centimeters. It says Baofeng Corporation, but one of the things that is missing from here is an FCC ID. And this one here says CMIT ID 2012 FP 1942. So this radio was probably made in 2012 by looking at that, but I don't know what CMIT is. There's an FCC logo there. There's a CU logo there, and then ISO 9001. I'm sure this is ISO 9001. Pretty cool little radio though. So next up, I want to test and see if this thing is RF dirty or not. And in order for us to test and see if it's RF dirty, I am going to use my Tiny SA. And this is my old Nano BNA Tiny SA Go kit. And then I have a new Tiny SA Ultra that I am going to start making a Go kit for, but I haven't gotten there yet. So in the meantime, I'm now carrying around 2 different containers with 2 different things in them. And what I want to do is I want to plug the radio directly into the attenuator. And what this attenuator is going to do is it's going to remove 40 dB of signal strength up to 10 watts and lower it down so I don't hurt my Tiny SA. And I really don't want to hurt the Tiny SA because the Tiny SA actually costs more than this radio does. But what I'm going to do is I'm going to send power out of this radio through this attenuator, which is going to make it less painful for the Tiny SA, and we're going to be able to tell whether this thing is clean or dirty. And everybody says Baofengs are dirty. They're the worst radios out there. They're horrible. And this one's made in 2012 and doesn't even have an FCC ID. So who knows? And in order to do all that, we've got to set this up. I have a video on how to set all this stuff up. Let's zoom in. We'll just do it real quick. Hey, look, there I am. Measure harmonic 146.52 megahertz. And let's set the span to 0, which is full span. Display, draw a line, minus 16.02. And then make sure our external attenuation is accounted for, minus 40. Okay, and now we're gonna key down again. There we go. Takes it a little bit to sort itself out. And so these here, where you see 2, 3, 4, 5, 6, those are all harmonics. So this radio is transmitting on its primary frequency of 146.52, and it's also transmitting out again on every double frequency. So 146.52 times 2, times 3, times 4 is where you get these numbers from. And it's looking like that's as settled as it's gonna get. So what I'll do is I'll go back and I'll hit pause. And now I can let go of the key on the radio. And if you feel the attenuator, it actually gets a little bit warm. And so we can see there's two rules that the FCC requires for transmitters to be clean. And that is that you need to be 40 dB down from the primary at 293.6, which is 51 dB down from the primary. However, it is not below our reference line of minus 16.02. So this radio doesn't produce terribly dirty harmonics for what it is, but it is in fact dirty according to the Tiny SA. So pretty interesting stuff. There we go, that's even better. It is hard to film a reflective screen and also have light that you can see what's reflecting off of it, and also not be in the reflection yourself. All right, so that is 146.52 harmonics. And then this radio here comes with a relatively cheesy 2 meter and 70 centimeter antenna, and they call these things rubber ducks because they are rubber and they're kind of pointless. But now we have our radio, our antenna, and our extended battery. One of the first things that I did though was I switched out this antenna. And everybody will tell you that these rubber ducks are bad, so that's why I did it. I just accepted the hype, and you can see the difference in size. The rubber duck itself and then the super elastic signal stick is twice the size. There's the end of the signal stick. It's hard to see the green antenna on the green mat. Let's see, is it exactly twice the size or is it even more than twice the size? So there is my first switch. It's almost 3 times the size of the rubber duck antenna. There's actually an extra inch on top with the rubber duck number 3 versus the signal stick. And in order to do that, in order to use this antenna, which is a BNC type connector with the Baofeng radio, you need to get yourself an adapter. And so I have a bunch of these adapters because they come in like a 3-pack. And when you put this on, it looks like it was meant to be there. Look at that. You can actually see it's a little crooked if you're probably here in person. Probably can't see it so much over the camera. And then this fancy antenna will go on to the radio. Ta-da! These things are supposed to work better when you are outside, so I am outside and I am using the rubber duck. I'm going to try and program in from the front panel of the radio a repeater, and I'm going to try it with the rubber duck, and I'm going to try it with the signal stick antenna. Okay, so that repeater is opening up. I am on the B band, the lower band, and if I key up, and so we're going to take that antenna off, and now they're gone. We'll put the rubber duck back on.
There, Jeff, but figured I'd play around a little bit, see if it's working. I took it down from the roof and poured about a half a gallon of algae water out of the middle of the boom. Project, maybe take it into the VNA there and get some...
So we're indoors, and I'm still hearing them come through pretty good on the rubber duck. But again, this repeater is very close.
Well, I'm at my next stop, so that's...
Oh, I moved it closer to the wall. Interesting.
Yeah.
Next up, I needed to program the radio. And so I actually went out and made myself a cable and got all fancy like. This one here is for a Kenwood TM281 and it plugs into this FTDI board. But we're working on a Baofeng radio, so it is the same thing here. I have a set of cables that I got off of Amazon for a 2.5 millimeter and a 3.5 millimeter jack. So one for input, one for output. And then I made up this fancy cable with this fancy heat shrink, and I'm so proud of myself when I started out doing some ham radio stuff a while back. And this will plug into this board. This board is a USB to serial port device. And it's kind of interesting when you think about it, because what it is doing is it is sending digital data from the computer out of the serial port, but it gets interpreted as audio by the radio. And everything is analog. So what you would do with this is plug in your cables, plug in your transmit, receive, and ground, so your 3 wires here, and plug it into your computer and run a program called Chirp. Let's do some power output tests over on the bench. So I want to go to the A band. I want to pick 1, 4, 6,
5, 2, 0.
And I want to check my transmit power.
Menu.
Transmit power is set to high. And then over here we have our meter. MFJ is no longer with us at this point, but this meter is also made by Nisei, so there will be a link down below where you can take a look at this. And it is plugged into my dummy load. I'm going to key up on the radio, and that is high power, 3.2. Some of that's getting eaten up by the coax, but not a whole lot. Let's try
Menu.
a different power setting.
Power.
Low. That's all we have is high and low. Awesome. So this is low power. Huh, half a watt. Nice. Switch over to the B band.
4, 4, 6, 0, 0, 0. Menu.
Transmit power high. Why is it not transmitting?
4, 4, 4.
Oh, that's why. I have it set with an offset, and the offset's out of band. Let's go back to the A band then.
4, 4, 6, 0, 0, 0.
There we go. All right, what's our transmit
Menu.
power? Low.
Power. Confirm.
All right, 0.34 on 70 centimeter low power.
Menu. Power. Confirm. Power. Confirm.
All right, and then high power. Whoo! 1.75 watts. Nice. So when I was outside playing with the repeater that you guys had heard a little bit earlier, I was at 444 with a positive offset of 5 megahertz for 449. When I switched over to do the transmit power test on 70 centimeters, I switched to 446, the national calling frequency. 446 plus 5 is 451. 451 is out of band. This thing does not transmit out of band. That was kind of an accidental test. I was going to do that test, but I just did that test, and now I don't have to do that test. So I'm just telling you why I'm not doing that test, because I did that test. Right?
5, 5, 5, 0, 0. Cancel.
Can't even program it in.
5, 0, 0, 0, 0. Cancel.
Nope.
4, 4, 9, 0, 0, 0.
When you put in 449, that works. That's in band. Now let's do 451.
4, 5, 1, 0, 0. Cancel.
Can't do 451 either. There you go. So as you can see, they're not the best radios on the planet, but they do work. They do get things done. And towards the end there, you start to see just how much of a pain it is to do some programming or to undo some programming. So I was in VFO mode, variable frequency oscillator, which is a fancy way of saying I can change the frequency without changing memory channels. I can do freeform instead of locked into different channels. When I tried to switch frequencies that I was working on, I still had all that offset and tone stuff and whatnot, and it doesn't really hurt the test that I was doing, but it does make it kind of a pain because you have to remember that you did all that stuff, and if you don't know what that stuff is in the first place, how How are you going to remember that you did it? I guess this radio was invented back when memory was scarce, and the extra 3 bits of memory that it would have required to store all that data was very expensive. And that comes down to the real crux of the whole matter here. These radios are dirt cheap. And they are a lot of fun, and who cares if they get messed up or don't get messed up? Who cares if you leave it on the bleachers at Hamvention and can't find it ever again? It doesn't matter. Compared to a $600 radio or an $800 radio, this will get you started, this will get you having a lot of fun. There is a lot of things you can do with it. Speaking of things you can do with ham radio, there's a video right over here I think you'll enjoy next. Thanks for being awesome. I'll see you over there.